Good morning all of you. Today we are going to discuss the next part of this chapter, dual nature of radiation and matter. Today we are going to discuss about photon. We will discuss the characteristic of photon today. So basically what is photon? We know that photon is a packet of energy. We have compared the photon with a balloon, right? If a balloon is filled with some water or colorful water, then that we can compare that balloon with the photon. Okay, so when we throw the balloon to a surface, what happens? That balloon move and strike the surface, and the surface will change somewhat way. The color of the surface will change, right? In similar manner, when the photon will strike the metal surface, the metal surface has some changes. The metal surface starts illuminating, right? Brightness appear in the metal surface, right? So this there are some changes. What happens here? In the balloon case, there is some interaction between the balloon and the surfaces. Like this, like the balloon, here also, when the photons strike the metal surface, there also some interaction happens. Interaction between that photon and the metal surface happens. Interaction between photon and metal surface happens. So there are some changes. We can see some changes in the metal surface. Metal surface illuminate bright. We can हमें metal surface दिखता है. Okay. क्यों दिखता है? क्योंकि फोटोन स्ट्राइक किया, हमें ये उस जगह इल्यूमिनेट हो गया, साफ दिखाई दिया, ब्राइट हो गया, तो हमें वो जगह दिखाई देता है. Why? Because of interaction between photon and metal surfaces, right? Okay, so photon, what is photon? Photon is a packet of energy. Okay, photon is a packet of energy. लाइट, जो लाइट है, हम पहले उसको वेव मान के चल रहे थे, अब हम बोल रहे हैं लाइट इज मेड अप ऑफ फोटन्स. एक्चुअली लाइट में क्या है? फोटन्स है, पैकेट ऑफ एनर्जी है. व्हेन सपोज आई विल से हियर इट इज ए मेटल सरफेस एंड लाइट इज स्ट्राइकिंग द मेटल सरफेस, दैट मीन्स द पैकेट ऑफ फोटन्स, these are the photons, these are the packet of energies, these are striking the metal surface, these are striking the metal surfaces. Actually these are the photons, these are the packet of energies. So we are assuming here the light is made up of these photons. Light is made up of particles. Okay, so here that means we can say radiation or your light is made up of photons or made up of particles. So I can say radiation is made up of particles called photons. Radiation is made up of particles called photons. Second thing, what is the energy of each photon? If I consider this one photon, what will the energy of this photon? They are moving. They are moving means they have some energy. Without energy they can't move, na? So as they are moving, they have certain energy. What is the energy? How much they have energy? The energy of each photon equal to h into nu. According to Planck, energy of each photon equal to h into nu. What is h? H means h equal to your Planck's constant. H equal to your Planck's constant. H is your Planck's constant. And what is nu? Nu is the frequency of light. Frequency of light. Frequency of light. So H is, what is H? H equal to Planck's constant, whose value is 6.63 into 10 to the power minus 33. Its value is 6.63 into 10 to the power minus 34. 6.63 into 10 to the minus 34. Okay, and nu is the frequency. We know that frequency is related to the color of the light. Red has different frequency, blue has different frequency, violet has different frequency. So frequency is related to the color of the light. So if someone asks you what is the energy of photon, each photon has energy h nu. h nu, where h is Planck's constant and nu is the frequency of the light, So I can say each photon is a packet of energy. It is a, what is photon? It is a packet of energy. And what is, how much energy? It is h nu. I am saying that each photon is a packet of energy. तो भाई ये पैकेट ऑफ एनर्जी है, इस पैकेट में कितना एनर्जी है ना, h न्यू. इस पैकेट में कितना एनर्जी होगा, h न्यू. ओके, डिफरेंट कलर का डिफरेंट फ्रीक्वेंसी होता है. तो रेड कलर सपोज आई से रेड कलर में जो फोटोन होगा उसका एनर्जी जितना होगा, वायोलेट में जो फोटोन होगा उसका एनर्जी अलग होगा. तो इस पैकेट, हर एक पैकेट होता है, फोटोन एक पैकेट ऑफ एनर्जी. जैसे आप मान के चलिए बाजार में गए हैं, आपको तेल खरीदना है, तो पैकेट में तेल मिलता है, 500 ml वाला, 1 लीटर वाला तेल मिलता है, डिफरेंट पैकेट मिलता है. उसी तरह से इसके अंदर जितना एनर्जी है, इसके अंदर उससे ज़्यादा एनर्जी है. ये पैकेट अलग अलग पैकेट है. ओके, इस फोटोन के एनर्जी जितना होगा, इस फोटोन का एनर्जी थोड़ा अलग होगा. तो कलर के हिसाब से हर एक फोटोन का एनर्जी कुछ अलग होता है. फ्रीक्वेंसी के हिसाब से हर एक फोटोन का एनर्जी कुछ अलग ही होता है. नेक्स्ट थिंग, दैट फ्रीक्वेंसी एंड एनर्जी इज इंडिपेंडेंट ऑफ इंटेंसिटी. वी नो दैट फ्रीक्वेंसी कभी इंटेंसिटी को डिपेंड नहीं करता है. ओके, एंड एनर्जी, व्हाट इज एनर्जी, व्हाट इज द वैल्यू ऑफ एनर्जी? वी नो दैट एनर्जी इक्वल टू h इंटू न्यू. एनर्जी का वैल्यू कितना होता है, h इंटू न्यू. इट इज एनर्जी इज डिपेंडिंग ऑन न्यू और फ्रीक्वेंसी. एनर्जी इज डिपेंडिंग ऑन न्यू और फ्रीक्वेंसी. सो आई कैन से एनर्जी इज इंडिपेंडेंट ऑफ intensity. It is independent of intensity. So I can say frequency and energy are independent of intensity. Third thing, that photons are electrically neutral. Photon electrically neutral होते हैं, कोई उसमें चार्ज नहीं होता, इलेक्ट्रिक चार्ज नहीं होता फोटन में, right? So if a photon is electrically neutral, suppose it is a photon and it is electrically neutral. It is a neutral particle. When I'll place this neutral particle inside a charge, so the charged particle cannot affect this. Okay, because it is neutral, na? As it is neutral, the charge, electric charge cannot affect it. So when suppose I'll say it is a electric field, positive charge, negative charge. If I'll throw a photon here, it will move undeviated. Because as it is electrically neutral, electric field cannot affect it. So it will move undeviated. Similarly, I can say if I will place it in a magnetic field also, as it is a neutral particle, so a neutral particle will not affected by magnetic field also. It will move undeviated in a magnetic field also. So I can say photons are electrically neutral, so there will be no deflection in the presence of electric or magnetic field. In the presence of electric or magnetic field, there will be no deflection. It follows conservation of energy and momentum. That means, suppose it is a metal surface, there are lots of electrons are there in the metal surface, right? Suppose I will throw photon. Suppose one photon, we know that each photon interact with one electron, right? Suppose this photon will interact with this electron. Suppose this has energy of 9 joule. When this photon will strike the metal surface, strike this electron, what will happen? It will transfer all its energy to the electron. That means electron will gain 9 joule energy, and the energy of photon will become 0. That means total energy is now conserved. ये इसने क्या किया, सारा एनर्जी इलेक्ट्रॉन को दे दिया, तो इसके पास अभी एनर्जी कितना बचा, 0। तो बिफोर कोलिजन जितना एनर्जी था, आफ्टर कोलिजन उतना एनर्जी है, तो एनर्जी क्या हो गया, कंजर्व हो गया, टोटल एनर्जी इज कंजर्व्ड। सिमिलरली momentum also, when it will strike the electron, when the photon strike the electron, it will transfer all its momentum to the electron, it will transfer all its momentum to the electron. So electron will gain momentum and this photon will lose electron. In total momentum will be constant, total momentum will be constant, total momentum will be conserved. So I can say photon is following conservation of energy and momentum, it will follow the law of conservation. Next thing, that it does not follow conservation of number. What that means? That means, look, here it is a photon, it is striking the metal surface. For example, let us consider that suppose I have a balloon and I am throwing that balloon towards the surface. When the balloon strike the surface, what happens? मैंने बैलून के अंदर जितना पानी दिया था, पानी भरा था, वो कहाँ चला गया, सरफेस के ऊपर चला गया, बैलून फट जाएगा, वैनिश हो जाएगा, डिस्ट्रॉय हो जाएगा, राइट। सो बैलून विल डिस्ट्रॉय एंड टोटल एनर्जी विल ट्रांसफर टू द मेटल्स, टू द सरफेस, राइट। बट बैलून का क्या हुआ, डिस्ट्रॉय हो गया, पहले बैलून था, अब टकराने के बाद आफ्टर कोलिजन द बैलून डिस्ट्रॉयड। सिमिलरली बिफोर कोलिजन देयर इज फोटन, after collision it will strike the metal surface and the total photon will destroy, it will lose all its energy and it will destroy. That means before collision there was suppose there was one photon, but after collision there are 0 photons, there are 0 photons. Before collision there were one photon, after collision there exists 0 photon. So number is not equal, number does not remain constant here. So I can say number of photon is not conserved, number of the photons does not conserve. We can create photon or we can destroy the photon. For example, here we are destroying the photon. When the photon collide with the metal surface, it will destroy, right? So there is destruction. How can we create photon? Look, suppose it is some valence cell of it is some cell of some atom. It is a atom, positive charge. Here are some electrons. Suppose one electron excite and move to the upper surface, but we know that electron cannot live in the upper or lower cell. Again it have to come back to its original cell. To return to its original cell, it have to lose some energy. This electron will lose some energy. हमें पता है भाई, ये जब एनर्जी लूज करता है किस फॉर्म में लूज करता है, कि लाइट के फॉर्म में लूज करता है. इट विल लूज एनर्जी इन द फॉर्म ऑफ लाइट, इट विल लूज एनर्जी इन द फॉर्म ऑफ photons, right? That means we are creating photon here. Photons are created over here. So photon is created, we can create photon or we can destroy photon. So here the number is not conserved, we can create photon or we can destroy the photon. A simple सा example है भाई, matches. When you burn the matches, before burning there is no light. When we burn the when we do friction in the matchbox and the matches, what happens? We can see the light, we can see the photons, right? So there photons are created. We can create photons. So I can say number of the photons is not constant, number is not conserved. Last thing, that rest mass of photon is 0. We say that if we stop a photon, अगर हम फोटोन को रोक लेंगे तो क्या होगा, उसका अगर मास मेजर करेंगे उसका मास कितना होगा, 0 होगा. ओके, इफ यू स्टॉप द फोटोन its rest mass will be 0. Rest mass of the photon is 0. These are some characteristics of photon. First thing, let's again say it is radiation is made of particles called photon. And what is photon? Photon is a packet of energy having energy h nu. Energy is independent of intensity. It is electrical neutral and energy and momentum are conserved. Rest mass is 0, and last thing that there is no conservation of number. Number of photons is not conserved. We know from Einstein's very popular equation E equal to mc square, right? Equal to mc square. Here E is the energy, m is the change in mass, c is the speed of light. What is c? C is the speed of light. Okay, again we know, put some equation 1. We know that energy of each photon, energy of photon or energy of light equal to h nu, right? Energy equal to, I can say energy equal to h nu. Put some equation 2. If we compare equation 1 and 2, we can see left side is energy, right sides left sides are equal, so we can compare the right sides also. We can say comparing, I can say comparing equation 1 and 2, we can say mc square equal to h nu. Mc square equal to h nu. That means if we divide c on both the sides, what will get? Cancel out m into c equal to h nu by c. Okay, again we know that lambda into nu equal to what is velocity, right? Lambda into nu equal to velocity of light equal to c. So I have written lambda into nu equal to c, where lambda is the wavelength of light, nu is the frequency of light, and c is the velocity of light. I am writing it lambda wavelength of light, nu is the frequency of light, c is the speed of light. So we know that lambda into nu equal to c. That means we can say lambda equal to c by nu. Lambda equal to c by nu implies 1 by lambda equal to nu by c. Reversing this, we can say 1 by lambda equal to nu by c. Here in place of this I can put 1 by lambda. That means mc, what is mc? Mass into speed. It will give me momentum p equal to h into 1 by lambda. That means p equal to h by lambda, where what is p? P is the momentum of photon, and h is Planck's constant, lambda is the wavelength of light. Okay, that means here momentum of photon equal to h by lambda. It is very important equation. We know this is very popular equation, equal to mc square, but this equation is very important. P equal to h by lambda.